Chapter 2, Section 4, Reasoning with Properties from Algebra. The algebraic properties of equality are on page 96 of your book, but I'll quickly tell you about each one of them. To see it in writing, go ahead and flip to page 96. The addition property of equality states that you can add the same number to both sides of an equation and keep the equation equivalent. The subtraction property is very similar to the addition property. Basically, the difference is the subtraction property says that you can subtract the same number from both sides. The multiplication property says that you can multiply both sides of an equation by the same number. And the division property of equality states that you can divide both sides of an equation by the same number. The reflexive property basically states that if you have a, or the variable a, then a is equal to a. Or if you had 3, 3 is equal to 3. The symmetric property says that if a equals b, then you can flip it and you can say that b equals a. The transitive property is probably going to be a little bit hard to understand just on here, but you can search it or look on page 96. The transitive property says that if a equals b and b equals c, because both a and c equal b, then we can say that a equals c because we can say that they are equal to each other. And then the substitution property says that if you have a variable equal to some number, then you can plug in the number for the variable, or you can make your substitution. An example of a proof asks us to solve 3x plus 12 equals 8x minus 18 and write a reason for each step. When we're asked to reason or to write a proof, we always start with what we're given. We have to start with the 3x plus 12 equals 8x minus 18. The reason why we start with that is because that's the problem that was given to us. I can't just make some random problem up to solve and get the right answer for, the book. So you have to have something to start with. Now, if you think back to algebra, how to solve this equation, I'm going to go ahead and subtract 3x from both sides to combine my like terms, and that way I still have a positive x, or a positive variable to work with. If I have to subtract 3x from both sides, I get 12 equals 5x minus 18. That is the subtraction property of equality. I was subtracting the same thing, 3x, from both sides of my equation. Now, my next step would be to add 18 to both sides. When you add 18 to both sides, you get 30 equals 5x, and that's the addition property because I was adding 18 to both sides of my equation. Now that I have 30 equals 5x, I need to solve for x and isolate my variable, so I'm going to divide by 5 on both sides. 30 divided by 5 is 6, and the reason why I could do that is that it was the division property of equality. The next example says a child's dose C for a medicine with an adult dose of 500 milligrams can be found by using the child's age A in years in the formula A equals 24 over 500 C minus 1. A asks us to solve the formula for C and write a reason for each step, and part B asks us to use the result to find the child's dosage for an 8-year-old. Remember, when I'm asked to solve and I'm asked to reason, I always start with what was given to me. So I'm going to rewrite A equals 24 over 500 C minus 1, and the reason why I'm starting with that is because it was given to me. If I'm trying to isolate the variable C, the first thing I need to do is add 1 to both sides. So I have A plus 1 equals 24 over 500 C. I was adding 1 to both sides, which is the addition property of equality. Now this next step, I would be okay with you writing either way. When you're trying to get rid of multiplying by a fraction, you need to divide by 20. You can divide each side by 24 over 500. But dividing by a fraction is the same as multiplying by its inverse. Regardless of how you think about it, you should be able to get to 500 over 24 and then in parentheses a plus 1 equals c. I said it was the multiplication property of equality. I would be okay, and you could argue that it was the division property of equality, but remember when dividing by a fraction, you're actually multiplying by the reciprocal. Like I said, you could argue either one of those. I would personally be okay with either one of those because in my eyes, they are both correct. When you're dividing by a fraction, you're actually multiplying by the reciprocal. So you can think of it as multiplying or dividing. I've solved for C. C is by itself. Now for part B, it asks me to use the result to find the child's dosage for an 8-year-old. To do that, I'm going to plug in 8 for A. 8 plus 1 is 9, so I need to do 500 over 24 times 9. And when you do that, you get 187.5 grams. The properties of length and measure, we have are on page 98. We have the reflexive property, symmetric property, and transitive property. They're going to be very similar to the reflexive, symmetric, and transitive that we talked about with our algebraic properties. This example asks us to write a proof for the fact that we are given that AC equals BD, and it asks us to verify or prove that AB equals CD. If you notice, AC equals BD is what's given to us. They're asking us to verify, which basically means prove that AB equals CD. Always start with what you're given. The given information is that AC equals BD. If you notice, AC and BD are both parts of the segment, you could say that AC, using the segment addition postulate, is AB plus BC. And then you could also say that BD would be BC plus CD. Notice that both of these segments that we're trying to verify are equal, AB and CD, share the segment BC. So, remember I can add the same thing to both sides of my equation or my equal sign, and that is okay because of the addition property of equality. Because both AB and CD are sharing the part of the segment BC, I am going to add, I'm going to say that BC equals BC using the reflexive property, and now I'm going to subtract that from both sides. AC minus BC equals BD minus BC. I'm sorry, I was saying adding before. I was meaning to say subtracting. I can subtract BC from both sides of the first statement that I was given because of the subtraction property of equality. The reason why I would want to do that might make sense here in just a second. This is our first real proof, so I'm just kind of walking you through it, and I'll tell you why we're doing things as we go. As you begin to write your own proofs and get in the swing of writing them, you'll notice that sometimes you don't have a necessarily clear path to where you're going, but you're just trying things and you got to do something. A lot of these could also be in a different order, and we'll talk more about that here in just a second. Because I have the two segments AC and BD that I was given that they were equal, I'm going to go ahead and I'm going to use the segment addition postulate, and I'm going to say that part AB plus segment BC would equal the segment AC, and I'm going to say that BC plus CD equals BD. Using this information, I'm going to be able to use the subtraction property, and I'm going to say that from the last statement, the ones that say AB plus BC equals AC and BC plus CD equals BD, what I've done to both of those is I've subtracted BC from both sides. So notice now BC is being subtracted from AC and subtracted from BD. Because of the subtraction property of equality, I can subtract the same thing from both sides, and I will still have an equivalent equation. Now that I have that, if you look back to the third statement up here, I have AC minus BC equals BD minus BC. Notice that I could substitute in, down here, the second from the bottom, it says AB equals AC minus BC. Well, I have AC minus BC on the left side of my third statement. So I can substitute in, instead of AC minus BC, I can substitute in AB. And I can do the same thing with CD. Instead of BD minus BC, I can plug in CD. So I can say that AB equals AC by the substitution property of equality. This is a little bit hard to see because I am not actually in front of you pointing at the segments. So this might be a little bit more tricky to see on this video than it would be in person. If you don't see what I'm saying, then make sure that you ask for clarification in class or come in before or after school so that I can clarify, because it's a whole lot easier if I can kind of show you what I'm talking about as we're going. The last example says a baseball diamond is shown below. Notice we have a square, we have angle 1, 2, 3, and 4. It says the pitcher's mound is at angle 3. Use the information to find the measure of angle 4. So what I'm trying to find is the measure of angle 4. And then it gives me all of this given information. It says the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. The measure of angle 1 plus the measure of angle 2 equals 93. And the measure of angle 3 plus the measure of angle 4 equals 180. Always, always, always start with your givens. I was given that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 80. I was given the measure of angle 1 plus the measure of angle 2 is 93. I was also given that oh no, it's in the wrong order. I was also given that the measure of angle 3 plus the measure of angle 4 equals 180. I apologize. So right now, all I've said is the top 3 given statements. If you notice, my next reason is already there. I can substitute in. If you look at the second given piece of information, it says the measure of angle 1 plus the measure of angle 2 equals 93. I can plug in, I can take out the measure of angle 1 plus the measure of angle 2 from the first given, and I can plug in 93 for the measure of angle 1 plus the measure of angle 2. Now I still have plus angle 3, the measure of angle 3 equals 180, so I've just substituted in 93 for the measure of angle 1 plus the measure of angle 2. Then, for the subtraction property of equality, what I've done is I've taken 93 plus the measure of angle 3 equals 180, and I've subtracted 93 from both sides. When I subtract 93 from both sides, I find that the measure of angle 3 equals 87. Now, looking at the third given statement, I can use the substitution property, and I can say that 87, the measure of angle 3 is 87, so I can say 87 plus the measure of angle 4 equals 180. Again, I'm going to use the subtraction property, and I'm going to subtract 87 from both sides. When I do that, I find that the measure of angle 4 equals 93, and the reason is the subtraction property of equality. I apologize, those were out of order. Remember, you always start with your 3 givens, and then you're going to go from your givens and tell me what you can conclude based on the givens. We were trying to find the measure of angle 4, and we did do that. The assignment for today is on page 99. It's numbers 10 through 15, 16 through 22 even, and 36 through 50 even.